Hi, welcome to this quick video on the SenseItAll. So SenseItAll is, and I've got my SenseItAll in front of me, is both a Potentiostat for R&D purposes, for developing electrochemical assays, electrochemical sensors, etc. But it's also a MVP, a minimum viable prototype or product. The P when I say MVP, if you're doing something like a food quality test, then the P can sort of mean a product. But if it's in a medical diagnostic, then the P is going to have to mean prototype. So that said, it's got sort of the capability of doing something like square wave voltammetry or cyclovoltammetry or linear sweep voltammetry, or basically there's a QR code for all the major electrochemical methodologies, including amperometry, open circuit potentiometry, linear sweep voltammetry, cyclovoltammetry, square wave voltammetry, EIS, electrochemical impedance spectroscopy, etc. But then it's also got something a little bit different, which is it's got a capability of turning raw signal in real time into a concentration, and I'll essentially do a demonstration on that. So I think it has a sort of a uniqueness in the terms of, yes, it is a potentiostat, but the look and feel of this little instrument also means that it can be used in also kind of more sort of real world applications as well. So let me just go slightly, and as I say, it's got these QR codes. So these QR codes are kind of, and the app that I'm using, the SenseItAll app, is actually already launched on the Google Play Store and the Apple App Store. And these, we can drive these kind of methodologies. And as I say, there's actually a data pipe in there, which means that we can pre-process the data, analyze the data, and turn the data into actual concentrations. And then it means that we can actually launch, and these are the kind of assays that we've launched already: chili, ginger, pH, nitrates, total antioxidative capacity, glucose, potassium, testosterone, free chlorine, lead, caffeine, and resinoferatoxin. So this is kind of just a way of showing you that this device is kind of interesting, because you can use it both for developing academic papers, but actually at the same time it can also then go on to actually do real world assays as well. So what I might do now is actually do a quick demonstration for you. So at the moment, my phone says EIS because it's in the electrochemical impedance. I just want to kind of show you one of the latest that we've added to it, which is resinoferatoxin. I like that one because it's got such a nice bright red. But actually what I'm going to do now is the second most recent one, which is caffeine. So let me just scan that. So now I've got caffeine. So what I'll do is I'll take one of our screen printed electrodes. You can see the way we've kind of, it's not just a screen printed electrode anymore. It's kind of properly housed. You can you find that just keys into that really nicely. It's not it's not a slot. There's not this fear of ingression of liquid. I can just close that, and that's closed up. Or rather made an electrical connection with it. What I will now do is I'm just going to give this a quick name so that I can find the data later on, which is what I'm doing. Demo. I'll just call this caffeine 101. Right, done. Right, so there's the caffeine. I'll be able to find that later on. As you know, or probably know, one of the best things about electrochemistry is sample types don't have to be the world's most pure sample type in any way whatsoever. So what I'll do is I'm just going to grab 50 microliters. So I like electrochemistry because both samples are not necessarily perfectly pure or perfectly worked up, and also you don't need much sample now. So I'm just going to put the sample onto here, which I will do. Especially when it comes to medical stuff that people don't want to give you large amounts of blood, and it also helps in the R&D stage as well because you don't need lots of material. With that said, let me go forward and just hit. And now what it's going to do now is it's going to grab data in real time. We like to design all our assays to be we like them to be fast. We don't always get them to be fast, but if we can, we will make our assays fast. If you rule of thumb, if you can make an assay 2 minutes or less, then that's probably a good design input. So while that's uploading now, I just want to navigate to my so I just want to show you what we're doing is. So it's giving me a result. I wasn't trying to get accuracy on this particular test. I was just trying to get a result. But you can see here, it gives a nice user experience in terms of, it says upload complete, milligrams per gram is 60.2, so that means there's milligrams per gram of caffeine. There's 60 milligrams in a gram of caffeine in that particular sample. Now what I'll do is I'm just going to change screens for a second. This is really getting into the power now of the technology stack, especially when you're kind of in the development phase or when you're working with alpha and beta users. You know, there's you can basically go up there or go up to the cloud rather, because when it says upload complete, which it said on the app just now, what that means is I can actually go in here and I can see the name of the sample, the time and date of the sample, who gathered the sample. I can see, and I'll just maybe just turn this off for a second. I can see my caffeine signal, but there's a really powerful data engine actually in a proprietary system called Julie that ZP has developed really over the last 10 years. And I can see my caffeine peak here, but I've also got, you know, a sort of not secondary, but quite a major interference. That's not a little interference. There's more interference than there is actually caffeine. You could appreciate in a complex sample like a coffee, there's lots of polyphenols. It's said to be rich in antioxidants, and they're not all caffeine. But look at the power of this system that actually it's essentially baselined us just before the caffeine peak. So we are measuring the peak height here, but we're not getting our baseline essentially raised by the secondary. So I just went by the sort of secondary materials in there. Let me just go to tools here and just show you for a second what's going on here. We've got the capability of doing pre-processing. So we did what's called a iterative polynomial. So we actually told it, go and create, I'm not going to say, I say a synthetic baseline, because we wanted to create a synthetic baseline so that we didn't have this interference. And then we said, go and find the peak. Go and find that peak after you've done that. So we've done both pre-processing to get rid of the interference, and now we've done analysis, and we've not told it to go and look at a particular potential, let's say, but we've said go and look at around 1400 millivolts, and then we've given it a window to look in, and then fit it to a formula. We even told it how we prepared the sample through the dilution, and that means then that it's calculated, it's gone through those steps, and it did it in real time, and it's so it's taken peak height and turned it into milligrams per gram. So I think you can get a pretty good idea that that's actually quite a very new type of potentiostat. So I suppose in some ways, you know, so we have this SenseItAll. It's both an MVP and it's a potentiostat. It works really well with this kind of really a new type of screen printed electrode, I would argue, that we've brought to the R&D market. It's a new type because it's not these kind of flimsy types of electrodes. No, this is something that you could easily handle in the lab and also feel like you could give to people in the real world, and they could actually handle it as well. You saw us put the sample on there, but the SenseItAll instrument is actually driven by these QR codes. So I did a caffeine one. It sent the instructions to the instrument. The instrument sent the data back to the app. The app was then on my, I'm using my Wi-Fi connection. I actually sent the voltammetry data to the cloud. We processed it in Julie. We did pre-processing where we did that iterative polynomial baseline correction on it. And then we did the analysis where we actually said, go and find that peak. And when you find that peak, apply this linear calibration to it, and actually sent the result back to the phone as well. So this is definitely, I don't think, a kind of potentiostat that people are used to, let's say. This is something that's really intended to get people out of the lab and have more impact with that science. That impact can just be helping society, or can also be impactful by launching businesses as well. So if you've got any questions regarding this, please don't hesitate to reach out to us. Okay, thanks very much.